Welcome to the Explainer. So let's just get right into it. If you've been watching the hardware space lately, you already know the diagnosis for mid-2026 is, well, pretty brutal. Memory is just incredibly expensive right now, everywhere. Whether we're looking at standard RAM, high bandwidth memory, or even those blazing fast SSDs, costs have absolutely skyrocketed. And you know that old reliable cycle where tech just gets cheaper over time? Yeah, that relief isn't coming. We are officially in an industry-wide crunch, which means we really have to rethink how we resource our projects, or honestly, we're going to get priced right out of the game. So, how exactly do you survive a squeeze like this? Most developers right now are totally stuck. They're basically arguing over a false dichotomy, a trap that is literally going to cost them thousands of dollars. They sit there debating the pros and cons of two very specific paths and completely miss the absolute best move on the board. To break out of that trap, here is our game plan for this explainer. First, we'll break down that false dichotomy. Then, we'll look at levers 1 and 2, build versus rent. After that, lever 3, which I call the Quantize plot twist. Then we'll cover the honest limits of all this, and finally, wrap it up with a solid decision framework. Okay, part 1, the false dichotomy, or treating memory as a fixed cost. See, when faced with these crazy hardware prices, almost the entire industry makes the exact same mistake. They treat their memory requirement like it's some unchangeable law of physics. They look at a model's size on paper and think, well, I guess that's exactly how much memory I absolutely have to go buy. It's just a fundamental misunderstanding of how modern model architecture actually works. And because people think that way, they limit themselves to two pretty painful choices: either shelling out to buy your own hardware or paying a premium to rent from the cloud. Before we get to the third option, the real game changer, we kind of need to look at these first two levers. We need to see exactly where these hidden costs are bleeding everyone's budgets dry. Because if you buy into the idea that your memory footprint is absolutely set in stone, your only logical next step is figuring out where to host that massive footprint. Which brings us to section 2, levers 1 and 2, build versus rent. Let's quickly compare these two traditional venues for hosting your models, because the truth is, neither is universally better than the other. Each one actually has a very specific, very strict use case. It's really all about matching the financial model to the actual rhythm of your specific workload. It essentially boils down to this: owning is way cheaper long-term if your work is steady, high utilization, maybe privacy sensitive, and always on. If you've got a model running for hours a day, every single day, building a local box is a massive win. Over its lifetime, a rig you own can easily cost half of what an equivalent cloud instance would. But you can't exactly go out and buy half a GPU cluster just for a 2-week experiment, right? So if your traffic is elastic, spiky, or totally uncertain, renting makes sense. The cloud providers are basically acting as your hedge against scarce hardware, letting you pay only for what you actually use. So if you're in one of those camps, here are the tactics. If you're building, the smart discipline right now is right-sizing to 24 gigs of VRAM. People are literally scooping up used RTX 3090s just to maximize that VRAM per dollar ratio, or they're leveraging the unified memory in Apple Silicon. Now, if you're renting, you've got to play defense. Cloud instances are getting pricier, especially the memory-optimized ones. You absolutely need to lock in reserve terms. And honestly, you have to realize that idle RAM is the single most expensive line item on your invoice right now. Both of these tactics, they're just ways to survive the bidding war. But here is section 3, lever 3, the Quantize plot twist. What if you just didn't fight that war? What if your memory requirement wasn't actually fixed in the first place? What if we could completely change the physics of the deployment?
This brings us to quantization. The act of making an AI model needs significantly less memory without sacrificing its capabilities. This is absolutely the most powerful part of the whole strategy. It's the cheapest lever you have, and it lowers your bill regardless of whether you decided to build or rent. Instead of paying those insane premium rates for more RAM, modern compression just lets you shrink the model itself. And the craziest part? It does this with an incredibly tiny hit to the actual quality of your output.
Now, there are two totally distinct knobs you can turn here, and mixing them up is probably the most common mistake I see developers make. The first knob is weight quantization. The weights are basically the largest fixed cost just to get your model loaded up. By compressing these parameters from a standard 16-bit down to 4-bit, you are directly attacking the sheer bulk of the model's footprint. And the math here is wild. This optimization, specifically using a format known as Q4_K_M, literally cuts your memory footprint by nearly 4 times. 4 times. It is a total game changer. It is without a doubt the single most impactful optimization you can make if you want to cram a massive, powerful model onto the hardware you already have sitting on your desk. And the best part? It gives you that 4x shrink while holding on to roughly 95% of the model's full precision quality. You get a massive capability boost on the gear you already own. This right here is exactly why the Q4 format is what the serious local AI crowd actually runs in production. But, and this is a big but, weights are really only half the battle. Things get crazy once a conversation actually starts. Enter the second knob, KV cache compression. This shrinks the temporary memory that grows alongside your conversation. Watch how fast this scales out of control. At 128,000 tokens, the KV cache alone for a 70 billion parameter model can eat up 40 gigabytes. That's on top of its weights. It's basically like the model is hoarding memory just to remember how your conversation started. This cache is a totally separate beast, and it quickly becomes your biggest bottleneck for long chats or deep document analysis. So how do we fix it? Well, right now, the standard FP8 format safely cuts that cache in half with barely any quality loss. But looking ahead to Google's newly unveiled TurboQuant, which drops in March 2026, you're looking at a staggering 6x reduction, taking it down to roughly 3 bits with near zero accuracy loss. Think about that. If you stack these two knobs, Q4 for the weights and FP8, or eventually TurboQuant for the cache, a model that used to demand 18 gigs suddenly fits comfortably into 12. You literally unlock a higher tier of hardware capability without spending a single dime on more memory. All right, Section 4, the honest limits. As your enthusiastic guide through all this, I have to make sure we don't fall into the trap of overselling this as pure magic. Quantization offers incredible leverage, for sure, but it absolutely has boundaries. And if you push past them, you're going to wreck your deployment. So here are the caveats. First, quantization buys you maybe 1 or 2 hardware tiers. It doesn't make your memory infinite. Also, if you push your weights below Q4, you are going to visibly degrade the model, especially on reasoning and coding tasks. That is just not the place to be cheap. Second, remember that TurboQuant is a near-future upgrade. It's not just a toggle you can flip in major frameworks today. Treat it as an upgrade you'll adopt the second it lands in your runtime. And finally, let's talk about MO, or mixture of experts. Don't confuse speed with size. MO models run super fast because they only use a fraction of their parameters at a time, but all those experts still have to physically sit in your RAM. It's a compute win, not a free memory cut. Moving on to Section 5, the decision framework. Let's bring this all together. We've looked at the traditional venues, we've looked at the compression plot twist, so how do we actually synthesize all this data into a final unified strategy to beat the 2026 squeeze? Here is your foundational rule. Before you ever spec out a custom build, before you ever spin up a rented cloud instance, your core rule must always be quantize first. If you have steady, high utilization workloads, yes, absolutely build your own right-sized rig. If you have elastic, spiky traffic, go ahead and rent defensively. But no matter which of those paths you're forced to take, shrinking the requirement first via Q4 weights and an optimized KV cache is the one universal move that slashes your costs almost for free. And that is the massive paradigm shift here. Stop throwing your budget at the hardware squeeze and start shrinking the requirement itself. Like the quote says, the individual's best response isn't to win the bidding war for that memory. It's to opt partway out of it by needing less. Everyone else out there is panicking, fighting over vastly more expensive memory. Let them fight. Your strategy is to calmly walk away from that bidding war by mathematically making your AI models need less space to begin with. So the next time you're staring down a massive invoice or a crazy hardware quote, don't just blindly ask yourself whether to build or rent. Ask yourself this one question instead. How little memory can this task actually take? Because if algorithms are already shrinking 40 gigabytes of data down to 3 bits right now in 2026, you really have to wonder, what hardware tier will your competitors be running on by 2027? Thanks for joining me on this explainer. It's time to go rethink your infrastructure.